Uni Junction Transistor. The Ujt was introduced in 1948 but did not become commercially available until 1952. Since then, this device has achieved great popularity due to the many reasons and applications. This is N-type bar and there are two connections. They are called bases, base B2 and base 1. They are the two terminals. And third terminal is when in the N-type bar, when it is topped with P-type impurities at one side near B2, that terminal is called emitter. So PN junction is formed. This device has one PN junction and 3 leads. It is commonly called a Uni Junction Transistor. Uni means single. This device is sometimes also called double-based diode. Because PN junction is a diode and 2 bases, double-based diode. Emitter is heavily topped, having many holes, and N region is lightly topped. So because the N region is lightly topped, so if the topping is less, the resistance will be more. That is around 5 to 10 kilo ohm. So if the emitter is not giving any voltage, that is emitter lead is open, base B1, base B2, and if we apply some potential between the two bases, then the N-type bar behaves as a resistor varying from 5 to 10 kilo ohm. And this emitter actually forms a diode, PN junction diode, and this diode is somewhere near to P2. So this is emitter terminal and it is open. The symbol of the Ujt is like this, the 2 bases and then the emitter terminal. It is bent and arrow involved. This arrow shows the ammeter current, direction of the ammeter current. Under operation, let me consider the first case. First case means we will not give any potential to the ammeter. Between the two bases, we are applying a potential difference. The current will pass and the N-type bar behaves as a resistor. Let if the voltage is 10 volt, then the potential will be distributed from +5 to -5 and difference becomes of 10 volt. This is ammeter P-type and one terminal to the base B1 common. No voltage is given to ammeter. You know, at ammeter the N-type is at +3, so PN junction becomes reverse biased with no voltage to ammeter. Look, just near the PN junction diode, voltage over the N is positive. So this battery is VPP. With VPP what happens? A potential gradient is established over the resistor. So that is very important. At the diode side, PN junction diode, at the end there is VPP makes a positive potential. So the diode becomes reverse biased. Now there are some important points. Ammeter is located near to B2 and then more than half of the VPP appears between the ammeter and base B1 because this is longer resistor. The voltage V1 is between the diode and the B1, and this V1 makes the diode reverse biased. On the PN junction diode. So that's why when we don't give any voltage to ammeter, then there will be no ammeter current. That is, ammeter current is cut off. But of course, small leakage current may flow due to minority carriers. So this is the graph between ammeter current along x-axis, voltage along the y-axis. So here the negative current means leakage current. So there is leakage current when there is no ammeter voltage. So this is leakage current. Generally we take voltage along x-axis and current along y, but here the graph is different. Current is along x and voltage is along y. This you to remember, and there is a particular reason of it. Now if we give the positive voltage to the emitter, the PN junction then will remain reverse biased so long as the emitter voltage is less than the reverse biasing voltage V1. So this is forward bias, emitter current VE, IE. Now we draw the graph between VE and IE. VE is variable. Now because we are giving VE and slowly it is increased, so it makes the leakage current 0 and then the forward current starts rising. So this is the graph. When VE is increasing, leakage current is decreasing, and here leakage current becomes 0 at this point. Leakage current at this point is 0. So at this point the voltage is VP, peak voltage, and current is the peak current IP. So if the input voltage to ammeter exceeds the V1, the PN junction becomes, what happened to PN junction? It becomes forward biased. So this is V1 reverse biasing, VE forward biasing. VE exceeds when the V1 ammeter current starts. The holes are injected by the ammeter and they are attracted towards B1 because B1 is at negative potential. Ammeter current will flow from ammeter to B1. That is the whole current. So holes are injected by the ammeter from P-side material into the N-type bar. Thereby constituting whole current. Because whole current is flowing ammeter to B1, what happens? It makes the resistor between ammeter and B1 to the low value. As resistance comes down, the voltage decreases. Voltage drops. Voltage drop from ammeter to P1 decreases. And hence ammeter current IE further increases. This process continues, that voltage is decreasing and current is increasing. This is very, very important. This is negative resistance part, because VE is becoming less, IE is becoming more and more. That is the negative resistance part. And we reached a valley point. So this is negative resistance, very, very important. Voltage down and current increases. They are reverse. So negative resistance. After valley point there is a saturation. Current becomes limited due to power supply. So this is IV. Because more and more holes are injected, as the now diode is forward biased, so condition of saturation will be reached, and current will come in a limit because of the power supply. Then device is called on state, that the UJT is on. But on the other hand, if a negative pulse is applied to a meter, the PN junction, it is already reverse biased, but if negative potential is applied, it becomes more reverse biased, and there will be no ammeter current, so it is cut off. Then UJT is called off state. The two states, on state, off state. So B2, B1, potential between B2 and B1, PN junction, ammeter is given, diode is given reverse biased, so there will be no ammeter current, so this UJT is in off state. Again, the equivalent diagram of UJT. The voltage is VPP, two resistors. This is variable. Here is the diode, and here is VE, and here is ammeter current. Across diode the voltage is VD. RBB is made up of RB1 plus RB2. Voltage across RB1 is V1. V1 is, first of all we find current VBB upon RB1 plus RB2. This is current. Current into resistance RB1 becomes voltage V1. So this is the current VBB upon RB1 plus RB2. Now rearranging this RB1, this is called eta. This is just a number because the ratio of the similar quantities, and it is called intrinsic standoff ratio. So voltage across RB1 is eta into VBB. This voltage makes the diode reverse biased. Therefore, ammeter current is 0 without any ammeter voltage. So here V1 is eta into VBB. If now progressively rising positive voltage is given to ammeter, which makes it forward biased. When input voltage exceeds the eta VBB by VD. VD is the voltage across the diode. Then forward voltage drop across the diode VP. That is the peak voltage eta VBB plus VD. This is peak point voltage. VD is the forward voltage drop across the diode. It is 0.7 approximately. So this is VP here, this point. Now conclusion is, if VE ammeter voltage is less than the peak point voltage, then the diode, then PN junction diode is said to be reverse biased and UJT is off. There will be no ammeter current and it is called off state. and if the emitter voltage is equal or greater than Vp, Vp, just crossing Vp, what happen? Rb falls down from several thousand ohm to a very small value. With that, voltage comes down, current increases, and negative resistance. Okay, and UJT is called on. Then IE reach to the saturation value. Okay, thank you very much. Uni Junction Transistor. The UJT was introduced in 1948 but did not become commercially available until 1952. Since then, this device has achieved great popularity due to the many There are the different graphs for different VBB. If VBB is 5 volt, then this is the graph. Now VBB is changing, and if 8 volt, this is graph between IE and VE. If VBB is still more, 12 volt, this is the graph. So again, this is the VBB, different 15 volt, this is the graph. So the current also depends upon the VBB. Higher VBB, this graph becomes somewhat higher above. Okay.